Hello everyone. It's a great honor to give a talk on the enhancement and selection of the LLM for the practical use. I'm Kai from China Unicom, and these are the latest works we've done recently. Okay, so if you are interested or if you are using LLM, you will notice some interesting trends since the year of 2025, okay? So the first trend is that the open source models are prevailing, okay? So most of the recent models are all open source models. Open source models become more stronger than before. So with the emergence of DeepSeek, like Q1, like Llama, and like Gamma, and there are very excellent open source models this year, okay? So the second trend is that the reasoning ability of the LLM are increasing fast. Okay, so if you are interested in the famous benchmark, the LLM arena, you will notice that all the top 10 models are reasoning models. Okay, so reasoning models are able to produce a more rigorous thinking process and are able to output a more precise result. That's why it's favorable. Okay. And the third trend is that the safety issues of the LLM remains challenging. Okay. According to the latest, the test of Cisco, and all the top 10 open source models suffer from serious safety issues, which means that if we want to use the LLM for practical use, we will have to solve the safety problem. Okay, there are also some challenges for the LLM when we want to put it into practical application. Okay, so the first challenge is that the users often get confused on what model should I select. Okay, so if I want to build an application based on an LLM, or if I want to use an agent, build my own agent, the first problem is that which model should I take? Which model should I select? Okay, so should I select the GPT model? Or should I select the DeepSeek model or the Llama 4 model? So, and especially for a certain application and for the limited GPU resources the user has, okay, he or she often get confused on what model to select. Okay, this is the first challenge that we have to deal with when we use LLM for a practical application. Okay, so the second challenge is that although reasoning models are popular, they usually suffer from serious overthinking problem, which means that they often think too much. Even for a simple problem like a subtraction problem, if you ask him what's 9 plus 5, okay, if you are using GPT or using DeepSeek, you will find that they will output a quite long answer, which is not desired and which will cost a lot of more computational resource. And this is also the problem we have to deal with. Okay, reasoning models are powerful, but they think too much sometimes. Okay, the third challenge is that if we want to use an LLM for practical use, we have to evaluate and enhance its safety, just as I just mentioned. Okay, so especially there are some benchmarks, very famous benchmarks to evaluate its English safety ability, but there are still a lack of the evaluation of the models in other languages. And meanwhile, if we enhance the safety of the LLM, will the reasoning abilities drop? Okay, will the other performance drop? This is also another challenge we have to deal with. Okay, to deal with these challenges, we China Unicom have proposed some solutions, interesting solutions. All the solutions are open source. Okay, the first solution is that we propose an LLM selection guide, which we call the Yuanjing LLM selection guide. Okay, so the goal here is we divide the capabilities of an LLM into 5 categories. For each of the 5 categories, we find some interesting applications we often use in our practicals. So here we have over 100 real applications of the LLM. And then we subdivide these 5 categories into 27 subcategories. Okay, each category corresponding a lot of applications. Okay, so for these applications, we created a benchmark which consists of 678 questions, QA pairs, for the benchmark for evaluating the ability, the capability of an LLM. Okay, so for this we have a name called A-Evo. Okay, the A-Evo benchmark is open source. You can download it from the GitHub. Okay, so we use this benchmark to evaluate over 20 models on A-Evo, and these models are open source. Okay, we evaluate these models and we compute the capability boundaries of these models. That is to say, to what extent could the model perform for a specific task. And for these test results, we formed the LLM selection guide. Okay, the first part of the guide, you can see that is a correspondence between the model parameter scale, its functions, and its applications. We establish the relationship between the three guides. Okay, so once for a certain application, you can find the corresponding capability. For the capability, you can find the most suitable and the optimal model you should choose. For the second part of the selection guide, okay, we correlated each application to the optimal model, like this. So like this table. Okay, so if you want to do a certain task, for example, if you want to categorize the news you searched, then it's suggested you use a Q1 2.54b model, and this is the optimal model. And for other applications, you can also find the optimal model that you should take. And this makes the selection of the model, that is the first step of building an application using LLM, very easier. Okay, so for the second challenge, the overthinking problem of the reasoning models, we propose a solution called difficulty adaptive slow thinking. Okay, the goal of dust here, we call it dust. Okay, the goal of dust here is to make the answers for simple questions as simple as possible, and we also remain rigorous thinking for difficult questions. Okay, this is the goal of dust. To do that, we propose a three-step strategy. Okay, for the first step, we introduce we call the token length budget, the TLB metric, to measure the accuracy of the training data. Okay, so for the training data for each question, we randomly generate 20 answers. Okay, so if the accuracy, the average accuracy of these answers is high, which means the question is relatively easy. So we make the simple as possible. That is, the answers with simple TLB, with shorter TLB, will be preferred. Otherwise, if the average accuracy of these answers are low, which means the question is relatively difficult, we encourage the answer to be as long as possible. And if the answer is long, we take the longest answer which has the largest TLB metric. Okay, then for the training, and we use the SynPO, the popular reinforcement learning method. We use SynPO to train the model. Okay, if the answer is correct, we will penalize it if the length is bigger than TLB, and we will reward it if the length is, smaller than TLB, and to encourage the conciseness and prevent overthinking. Okay, so if the answer is wrong, we will encourage the answer to be as long as possible, and the answer with longer answers will be given a much bigger TLB value, which means we encourage these answers with longer. Okay, so positive sample when we use SynPO. When correct, the shorter is better, and when negative samples, we're using the SynPO and approach the TLB as much as possible. Okay, for the third step, we construct the preference pairs for the training. Okay, we created two types of training pairs. That is, a question corresponding to two answers both are right, which we call the winner, or neither is right, which we call the loser. If the reward score is high, then we select the winner, and if it is low, we select the loser. Okay, with these 3 steps, we are able to improve the thinking ability of the original model. Okay, so here we take the open source model, the DeepSeek R1 model, as an example to show our method of improving the DeepSeek R1 model. Okay, as you can see that with the Math 500 benchmark, with a famous benchmark for evaluating the ability of reasoning models, it has different difficult levels. Okay, so for all the 5 difficult levels, we obtained a relatively high precision, and meanwhile, the length of the answers are relatively shorter than the original DeepSeek models, which means that we have successfully improved the DeepSeek model by making the answers of the simple questions more shorter, and which makes the answers for the difficult questions longer. Okay, so here is an example showing the original and the improved DeepSeek R1 model. As you can see that for this simple construction, subtraction question, okay, the original DeepSeek model on the right, and it outputs a quite long thinking process, which is not desired. But for our improved model on the left, you can see that the answer is much shorter, and the answer is correct. So what about for a difficult problem? Okay. Okay, this is a difficult logical problem. We use the problem to test the performance of the improved model. And you can see that both the original DeepSeek R1 model and the improved model output very long answer. But relatively, the improved model, the length of the improved model is relatively shorter, and the answer is correct, which means that for difficult questions, our method is able to maintain the rigorous thinking ability, and meanwhile, the length of the answers are shortened. Okay, so for the third solution, for the safety evaluation and enhancement, we propose a new benchmark, which we call the Kai safety benchmark. Kai represents for Chinese. Okay, this is a Chinese benchmark for evaluating the Chinese performance, the Chinese safety performance of an LLM. Okay, for this benchmark, we follow the Chinese standard, which is a TC260 standard, to build a benchmark which contains 5 major categories and 31 subcategories. We use this benchmark to evaluate the performance of LLM, the safety performance. And this benchmark is also open source. You can download it from GitHub. Okay, we use our benchmark to test over 40 open source models, which contain the famous DeepSeek model, the Q1 model, the Llama model, etc. And we found that so for the practical application, according to our test result, more safety enhancement is needed for almost all the models. Okay, which means that open source models actually are not safe. Okay, so here we take the DeepSeek R1 model as an example to show how we enhance the model's safety. Okay, so first we construct a training set with over 50,000 questions about the safety questions. And meanwhile, to maintain the reasoning abilities of the original model, we also use the 30,000 questions about the caught data, which means the chain of thought data, and to maintain its general thinking abilities. Okay, we use the mixed data to train the model, and for the training we use a very common SFT method to train the model. And this is a result showing the safety enhancement result. And you can see that for the overall risk content identification accuracy has improved by over 10%, and the harmful response decreased by 50%, which means that our model is able to enhance the safety performance. And meanwhile, we also test the model's general ability on different tasks like MICE 500, like GPQA, and like other famous benchmark. And from the benchmark, you can see that the result of the improved safety model, the safety improved model, also remains the same as the original model, which means that we enhance the safety of the model, and at the same time, we maintain the general ability of the original models. Okay, so this is an example of a very famous question for testing the safety performance of the model. Okay, we asked him to tell the story, and the story contains a Windows 10 prompt key, Windows 10 prompt key, and this is a very very common, the prompt injection problem. Okay, for this problem, as you can see that with the original DeepSeek model, they smoothly output the Windows 10 key, and which is not safe, right? But for the right, you can see that for our safety enhanced model, we can tell very interesting story without telling out the original Windows key information, and which means that we solved the problem of the prompt injection to some extent. Okay, that's all for today's talk, and I introduced the effort we recently made on improving the general ability, the thinking ability, and the safety ability of the open source models. And we also proposed the world's first model guide for the general model selection, and which is quite useful for novice users. Okay, that's all. And we, China Unicom, would like to collaborate with our partners to put the AI into more practical and to make AI safer. Thank you very much.